Okay, so now we'll look at the total correctness questions. So for the total correctness, we need to find a variant, and the variant is a term that should decrease after each iteration of the loop, and it should be greater than or equal to 0 when the loop is entered. So if we look at what's happening here, y is going up and up and up, and the code's only executed when x is less than or equal to a. So a good choice of variant is probably going to be a take x, because as x goes up, a take x goes down. So we conjecture E is equivalent to a take x. That's sufficient for this question. You don't need any justification for it. It doesn't specify that we need it. Right, for the variant E that you've identified above, give a proof of the premise of the while rule for total correctness. Okay, so we need to prove P. What was P? P was our invariant, which was x is equal to 2y. So we need to prove x is equal to 2y, and x is less than a, and E is equal to k. What's E? A take x, and a take x is equal to k. The body of the code, which was increment x by 2, increment y by 1. The post condition is P and E strictly less than k. So x equals 2y and a take x less than k. And we also have to argue why this is true. So I guess we can just do that up here. So P, x equals 2y, and x is less than a. Does that imply a take x is greater than or equal to 0? Looks like it, right? Because x equals 2y and x less than a implies x is less than a, implies a is greater than x, implies a is greater than or equal to x, implies a take x is greater than or equal to 0. That's sufficient justification as far as I'm concerned. So let's prove this thing. We only need to prove the premise of the while rule. We don't actually need to do the while rule itself. We just need to prove the thing that you use just before you use the while rule, i.e. prove this whole thing. So we have to use sequencing here. Yada yada yada, do sequencing. Something. Same something. And a take x is strictly less than k. Alright. Do something backwards. So we have x equals 2y plus 1. And a take x is strictly less than k. So we have x equals 2y plus 1. And a take x is less than k. We need, so this is true by assignment. This is true by sequencing, but this is not yet proven. So, what can we do? We can probably do... Let's try something backwards again, because it didn't work last time, so I'm sure it'll work again this time. I didn't even do the assignment after that. X plus 2 equals 2. Oh, I see what I did wrong. I copied up the wrong post condition. Whoops. Okay. So replace the x's here with x plus 2's here. Straight by assignment. And then, if we pray really hard, hopefully this thing implies that thing. X equals 2y, and x less than a, and a take x equal to k. This term implies that term. And if a take x is equal to k, then a take more stuff is strictly less than k. Alright, now we're in business. Logic, precondition strengthening, lines something, needs line numbers, 1, 2, 3, 4, 5. Precondition strengthening, 1, 2, and 1. assignment and sequencing 3 and 4. That wasn't so bad. How did I not do it the first time around? Who knows? I will. See, end of exam. Well, I guess now you get to see, under exam conditions, how I do. Poorly. And that was question 4B, or C. Yeah, B, IV. Okay? Ta-da.